Well, thank you very much. As part of our pre-flight checks, could we close the doors? I won't ask for the windows closed. So yes, this is the Language of Aviation. My name's Gavan Fantom, and we're going to be looking at a little bit today about how language is used in the world of aviation to keep us all safe. A little bit about me. I have a pilot's license. I am a pilot. I can fly small aeroplanes. I can't fly big airliners. That's a lot more training. I can fly them during the day, not at night. Again, more training. I can fly them in good weather. I can't fly through clouds. Again, more training. And I'm not allowed to get paid. Again, more training. I am also not an instructor. This is not official training, I have to say this, just in case anybody tries to use this as credits towards a pilot's qualification. This is not. This is just for your entertainment and general interest. Hopefully you'll find it interesting. So there's a few areas in aviation where language is used. And the first one that everybody thinks of, I think, is radio communications. And we will, of course, talk quite a lot about radio communications. But I wanted to make the point that it's not just on the radio that we use language in a standardized way. Before I go flying, and before any other pilot goes flying, I want to know what the weather is doing. I want to know if I'm about to take off and get myself into a really uncomfortable situation, flying through the clouds that I'm not allowed to fly through, and in situations where it's going to be dangerous. I need to know if I need to go somewhere else, or I need to know if I need to just stay on the ground. I also have other sources of information where I can find out information that's critical to the safety of the flight, or might be critical to the safety of the flight. And the main one of those is the NOTAM system, which I'll get onto as well. If I'm flying internationally, or if I'm flying for an airline, which I'm not allowed to do, or another instrument flight, which I'm not allowed to do, I have to file a flight plan. That's another piece of standardized language that, in this case, doesn't come to me, it goes from me to air traffic control. And the least standard and least regulated part of this is when I'm talking to other pilots and passengers. Now, stick your hands up if you've been a passenger in an aircraft. Right, that's most people here, great. Stick your hand up if you've been in a small aircraft.
What does mean small?
Let's say less than 20 people. Great. Now stick your hand up if you've been allowed to fly the aeroplane. Oh, a few people, great. And stick your hand up if you have a pilot's license. Hey, excellent. Right, so I'm just going to talk about two of the elements from the briefings, and then we're going to move on to the radio. So now you're all going to regret coming here because I'm going to hit you with a wall of text. So this is a weather observation and a weather forecast. Now, I know at least one person in the room is going to be able to read this, maybe two or three. That's fine. I don't expect you all to be able to read all of this. I'm not even going to take you through every last little bit of it, but I wanted to demonstrate that the reason that this works is that you know what to expect. It's in a standard format. And the very first thing that you need to know, if you're reading this, is where is the forecast for? That's the very first bit here, EGLL. Does anybody know what that code means? Yeah, one person does. That's London Heathrow Airport. Right. So they get a very full weather forecast along with their observations because that's quite a big airport. And the very next thing we have is the date and the time. So this observation was on Tuesday the 29th, shortly before I got in my car and drove to Heathrow to get on an aeroplane. Yeah. And this observation was at 1650 Zulu. So that's in UTC. All aviation timing is in UTC. because if you fly over a time zone boundary, it can get very confusing otherwise. Then we'll go on a little bit. The next bit is auto. It tells you that it's an automated weather report. And then you have wind information. So as always, the wind information comes at this point. And this is 010 degrees at 8 knots. For people not familiar with knots, 1 knot is approximately 1.7, 1.8 kilometers per hour. And the wind is varying between 350 degrees and 050 degrees. So it takes a bit of decoding, but if you work through it, it does make sense. Then we go on to visibility. It's not a very nice day on Tuesday. 5,000 meters visibility, 5 kilometers, and haze. Not nice. Now, fortunately, I was leaving this flight to the airlines, who can fly through clouds. If that was me, I wouldn't have taken off that day. The next bit is about the clouds. Scattered clouds at 700 feet. That's, about 200 and something meters. It's not very high. Do you not want to fly through clouds on my license? And the next bit, these slashes here mean that there's some missing information or information not reported. But the really important bit for me as a pilot is these next two letters, CB. CB is bad news. CB stands for cumulonimbus and is also more commonly known as thunderstorm clouds. We carry on a bit about the general weather. 16 degrees Celsius at the surface and 15 degrees Celsius is the dew point. That's the point at which you get 100% humidity. So that's where, when the temperature goes down to 15 degrees, you start getting clouds forming. And then we have the air pressure of 1014. So the air pressure is always important to pilots because that's what we use to set the altimeter, and all of our height and altitude measurements and indications in the aircraft are based on knowing the air pressure. Our ATS is recent thunderstorms. So again, bad news, right? I would not be taking off on this day, right? Thunderstorm clouds, thunderstorms, low clouds, low visibility. It's not a good day. And then we have tempo SHRA broken 800. So in the next couple of hours, rain showers and broken clouds at 800 feet. So I'm glad I wasn't the pilot that day, is all I'm saying. The rest of this is a similar format and is the weather forecast. So Heathrow gets quite a good forecast that covers a long time because there's airliners and so on that are relying on it. I'm not going to go through all of this because mostly it's different periods of time in the same format. So we've got the airport Heathrow, 29th from the weather forecast at 1704 Zulu, ranging from 1800 hours on the 29th to 2400 hours on the 30th. 020 degrees, 8 knots, greater than 10 kilometers visibility. There's only so far you can represent in 4 digits, and that's 9999. And scattered clouds at 1,400 feet. Okay. And then all of these are the are periods within the forecast, and the second one down with a probability of 30%. Tempo means for a time period from 1800 hours to 2200 hours, 4,000 meters visibility, only 4 kilometers. Heavy rain showers and thunderstorms, heavy rain and thunderstorms, broken clouds at 800 feet, and the really scary one, broken clouds at 4,000 feet with cumulonimbus. So I'm not going to go through the rest of it, but this gives you a taste of the sort of condensed written form that we receive weather information in. And the other written form that I'm going to show you is the NOTAMs. NOTAM is a term that's been in use for about a century. It's notice to airmen, and this is a way of communicating information to pilots that might be relevant to flights. This is an example of one, but before I go flying, I will look for all NOTAMs relevant to the area in which I'm going to be flying, and I might get 20, 40, maybe 50 NOTAMs to look through, some of which will be relevant, some won't. We can ignore the first line. That's actually designed for computers to be able to read nowadays, but the rest of it is a standard form. EGBB is the airport code for Birmingham Airport, again in the UK, maybe less well known than Heathrow, but maybe some of you have heard of Birmingham. We've got the time period for which it's valid and some relatively normal English text with some abbreviations and some keywords. So we've got lit mobile crane operating at these coordinates, brackets Birmingham, 229 degrees magnetic, 2,924 meters from airport. So that's far enough away. I'm not too worried about this, but it's worth knowing about. Maximum height, 136 feet above ground level, or 488 feet above mean sea level. So this above ground level and above mean sea level are very common terms in aviation. We deal with heights and altitudes all the time, so that's very important information for the flight planning. 136 feet above the ground is not too high. I'm not too worried about this when it's 3 kilometers away from the airport. So, there is a standard language in aviation, and that language is English. It's not necessarily the same spoken English that you and I speak here today. It is a working form of the language for this specific type of activity. But it is English, and that is standardized across the world, and it was standardized in 1951 by the International Civil Aviation Organization. And that's established by international treaty, which I think all but about 3 countries in the world are signed up to. There are other languages that may be used in certain areas. There is a list of them, which is not as long as you might think. But for example, in China, pilots and air traffic control speak to each other in Chinese. But where there's a possibility that there might be an international air service, English has to be available on the list of languages that an air traffic service unit might speak. Now, we're over 10 minutes in. It's time to talk about safety. Absolutely everything, almost everything, but very nearly everything in aviation is based on safety. Think about it. If you're flying through the air, 10 kilometers up in the air, in a metal tube, it's kind of important that nothing goes wrong. Right? It's very important. And there are risks. And we work very hard in the aviation world to mitigate those risks, to reduce the risks to the absolute minimum that we can. And that's very important. If we didn't do that, nobody would fly. When something goes wrong, it's investigated, even if it's the smallest thing, but also for the biggest things, it's investigated. Most countries have some sort of government department that's responsible for investigations, and those investigations can run, the reports can run to hundreds of pages about every minute little detail about everything that led up to an accident or an incident. And out of these investigations, out of the recommendations from these, we always work to improve the procedures. Everything in aviation revolves around procedures, from the checklists that you have in the aircraft to the way you talk on the radio, which we'll cover in a little bit. And a lot of this is regulated. This isn't just recommendations. I mean, a lot of it is, but there are laws in place that say this authority, this organization has the authority to tell you how you must do things, and if you do not follow these procedures, you could be prosecuted. So having talked about safety and how everything is very safe, now we're going to look at what happens when it goes wrong. So we are going to look at, unfortunately, an absolutely tragic accident, and we're going to look at this because this was the driving force behind a lot of the changes and a lot of the standard phraseology that we now use. This wasn't just a few years ago, this was back in 1977. And Gran Canaria Airport was closed because there was a bomb that exploded. And there was a warning of a second bomb. So that airport was closed. Now you have a lot of aircraft already in the sky that are on their way to land at that airport. Of course, they have to go somewhere. So they went to Los Rodeos Airport in Tenerife, which is the nearest alternative. That's a much smaller airport, and the parking area quickly filled up, and they had to start parking aircraft on the one taxiway at that airport. I don't know how well you can see this picture because the projector is not very bright, but you can probably make out the runway in this picture. This is Los Rodeos Airport in Tenerife, and parallel to it on this side you have one taxiway. And on the other side of that, you have the parking area. So you can see there, if you've got aircraft parked on the taxiway, nobody's going anywhere. Later on, Gran Canaria Airport reopens, and we start trying to move the aircraft. Now we're going to look at two aircraft in particular, KLM Flight 4805, and Pan Am Flight 1736. Now KLM has just been refueling and caused an awful lot of confusion and blockage, so nobody could get past them while they were refueling, but they were the first that were in a position to be able to get to the runway. So they taxied onto the runway, and because the taxiway was blocked, they had to taxi all the way down the runway to the other end, and turn round and sit and wait on the runway. In the meantime, the next aircraft behind them, this Pan Am 1736, also taxis down the runway. And the intention is that it will taxi about halfway down the runway, turn off at one of the intersections and rejoin the part of the taxiway that is not blocked. As this is happening, clouds roll in over the airport. Very low clouds at this point. This is quite a high airport, and this is fog. So by the time this is happening, the two aircraft can no longer see each other. Also, the control tower can't see what's happening on the runway. And this airport does not, or did not, have radar. So the only way that you can assure the safety is by communicating on the radio and every pilot reporting what's happening. And here's a crudely drawn diagram of the position of the two aircraft. That's KLM at the far end, sitting waiting at the end of the runway, ready to take off, and Pan Am in the middle of it, taxiing towards an intersection. So you can see where this is going already. Now, in 1977, the standard phraseology wasn't used as it is today. But this is what happened on the radio. KLM says, the KLM 4805 is now ready for takeoff and we are waiting for our ATC clearance. Now, ATC clearance is not the same thing as takeoff clearance. ATC clearance is instructions on what you can do after you've taken off. In this case, the tower provides that clearance. KLM 8705, so they got the call sign wrong already. KLM 8705, you are cleared to the Papa beacon, climb to and maintain flight level 90, right turn after takeoff, proceed with heading 40 until intercepting the 325 radial from Las Palmas VOR. And KLM quite correctly responds, reading back most of that. Roger sir, we are cleared to the Papa beacon, flight level 90, right turn out 040 until intercepting the 325. We are now at takeoff. Can anyone see the problem here? Right. The KLM captain had a number of pressures at this point. He was just a few minutes away from having to cancel the flight because his flight crew had worked very nearly the maximum number of hours they were allowed to work that day. He was very impatient, and he misunderstood a message which included the word cleared and included the word takeoff. Tower got suspicious about this. Okay, stand by for takeoff, I will call you. The Pan Am flight crew also got suspicious about this. And we're still taxiing down the runway, the Clipper 1736. Clipper is the call sign used by Pan Am. Unfortunately, they both transmitted this at the same time. And when you have two aircraft or two stations transmitting at the same time, all that you actually get to hear is beep. Not very helpful. So all the KLM flight crew heard was probably okay. So they don't realize there's a problem here. The tower says, Papa Alpha 1736, report the runway clear. So maybe a little bit of a clue here, but they got the call sign wrong here again. That should have been Clipper 1736. Okay, we'll report when we're clear. Thank you. But by this point, the KLM flight is already halfway down the runway. And unfortunately, well, when they're able to see each other, the Pan Am realizes this slightly sooner and manages to start a left turn off the runway. And the KLM tries to take off to avoid the accident, but clips the Pan Am flight and crashes 150 meters later. This is, apart from the September the 11th, 2001 terrorist attacks, this is the worst aviation accident in history to this day, with 583 people dead. But because of the Pan Am managing to start that turn, 61 people from the front of that plane survived. So I said earlier, everything's about safety, and when there's an accident, it's investigated and changes are made. And this accident was really the cause of taking standard phraseology a lot more seriously. Now this is linguistic prescriptivism taken to a whole new level, really. Nowadays, certainly the UK Civil Aviation Authority publishes for the UK the radio telephony manual. That's based on an international one. That's 374 pages long, I know, because I was reading it to research these slides. So standard phraseology is very important. It gives a sequence for things, it gives rules for what must be said when, and it's also that you know what to expect, you know which order it's in, and the important things get checked and confirmed. That checking and confirming is readbacks. Now, in this case, the KLM pilot did read back part of the clearance, but nowadays readbacks are a lot more strict. There are very definite items that must be read back exactly, and other things that must be read back in a way that contains the same information. A very specific rule is that you do not say the words takeoff until takeoff clearance is given. Right? If the word takeoff had not been used in that radio transmission, maybe somebody might have noticed this, or maybe it would have been harder to interpret that as takeoff clearance. We now always use the word departure until takeoff clearance is given. And now if you've got a situation where you've got an aircraft sat at the end of a runway waiting to take off, the ATC clearance will be said with the words hold position beforehand. It's very important because that makes it really clear. This is not a takeoff clearance, hold position, here's your ATC clearance, stand by. And the other thing which I could do a whole different talk about, and I'm just going to briefly touch on the slightest detail here, is crew resource management. And the part that's relevant here is there's specific training for the first officer to speak up if they see something that's wrong. And there's specific training for the captain to listen to the first officer and to provide an environment where the first officer feels safe and able to raise any concerns. So we're going to see some of this in action now. This was a large commercial flight, or two large commercial flights, but we're going to look at a small flight. And we're going to fly from the town of Polyglot, which is a small town, has a small general aviation airfield, with the kinds of planes that I fly, 2-seaters, 4-seaters, that kind of thing. And we're going to fly to Omniglot City, which is a larger airport, which has full air traffic control and has commercial jets flying into it, as well as us. So both of these airports have an aerodrome traffic zone around them, which is a small area near the airfield or the airport for making sure that you're talking to the airport. It's a small bit of usually controlled airspace. And Omniglot City has a larger area around it, a control zone, which you need permission to enter. The rest of the flight is outside controlled airspace, so we don't actually need permission to fly the rest of the flight, but we will need to ask permission to enter this controlled airspace. And we'll just talk through what happens on the radio, just as an example of standard phraseology. Now, every single line that you're going to see on this radio has come almost verbatim from the radio telephony manual. So all of this is standard phraseology. So this covers the situations for the entire flight. Now, in a situation where there's something unusual and it's not covered, you do revert back to normal English. But where there is a possibility to use the standard phraseology, this is what we use. So our initial contact, we make the call. Polyglot radio, Golf, Golf, Lima, Oscar, Tango, radio check 113.5, request departure information. We're a UK registered aircraft, which is the first G in the registration, and the rest of it is just the registration. We're making sure the radio works. We're asking the air traffic service unit, can you hear us? And we will also respond. And they respond, Golf, Golf, Lima, Oscar, Tango, Polyglot radio, readability 5, so they've heard us good. Runway 16, QNH 1015. So we have the runway and we have the air pressure. So this is for the altimeter. And we also report, we can hear you okay, readability 5, and read back the information, runway 16, QNH 1015, Golf, Golf, Lima, Oscar, Tango. Great. We're now talking to them. So we taxi to near the runway, we do our checks, and when we're ready for departure, not takeoff, departure, we say Golf, Golf, Lima, Oscar, Tango, ready for departure. Now this airport does not have air traffic control. We didn't have to ask permission to taxi. This has a less strict service called Air Ground Radio, who can't tell you what to do, they can just give you information. And this is common at a lot of smaller airfields. So we've called ready for departure and they respond back, Golf Oscar Tango. Now this is an abbreviated call sign, just saves a bit of time and saves a bit of tongue twisters, to be honest. No reported traffic, wind 14012. And we just acknowledge that with Golf Oscar Tango. Now notice they haven't said the word takeoff anywhere. This is because it's not air traffic control. They can't give us clearance to take off. They can't tell us to take off. They can't issue permission for that. So the word takeoff doesn't appear. We could now say taking off, but it's not necessary. So then we take off. So it's nice and simple so far. And we're leaving the area. Golf Oscar Tango, now leaving the ATZ, changing to Omniglot approach 124.125. And they respond, Golf Oscar Tango, Roger. Now who can tell me what Roger means? Ready? No?
I agree.
Ready, understand, agree, confirming. Yeah, okay. So Roger doesn't mean I understand or I agree, it just means I have received all of your last transmission. Other things that are commonly misunderstood. Who can tell me what over means?
I understand.
Over means I have finished my transmission and I expect a response. What about out?
End of communication.
Yeah, I have finished my transmission and I do not expect a response. What about over and out? Exactly. I have finished my transmission and I expect a response and I do not expect a response. It makes no sense. Okay. So moving on. Omniglot is a bigger airport, and large airports often try to save time on the radio by having an automated recording of the main information about the airport. It's called ATIS. So we tune into that, and this is usually read by a speech synthesizer or something similar, and we just tune into the radio, Oscar at first contact. Omniglot, ATIS, information Oscar, runway 05, wind 040 degrees, 8 knots, visibility 10 kilometers, broken at 5,000 feet, temperature 27, dew point 15, QNH 1014, QFE 1002, acknowledge information Oscar at first contact. Omniglot, ATIS, information Oscar, and at this point we tune the radio to something different because we've heard it all before. We might listen to it twice, writing down, actually literally writing down with pen and paper what we're hearing here. This saves time for air traffic control. And then we have another wall of text. This is where an airport with full air traffic control is a bit more complicated than the airport that we started from. Omniglot approach, Golf, Golf, Lima, Oscar, Tango, request join. So we're telling them what we want to do. We want to join, we want to come to their airport. Golf, Golf, Lima, Oscar, Tango, Omniglot approach, pass your message. Golf, Golf, Lima, Oscar, Tango, PA28 inbound from Polyglot, VFR 3,000 feet, QNH 1014, estimating zone boundary 25, Omniglot 30, information Oscar. Now that's a lot. Okay, but we're telling them a lot of information. We're telling them who we are, where we're coming from, where we're going. PA28 is the aircraft type. Inbound from Polyglot, I hope, is fairly self-explanatory. VFR means visual flight rules. There are two sets of rules that we can operate under. VFR is the one that I'm allowed to fly, where I look out the window and see where I'm going. That's why I can't fly through clouds, because I can't see anything if I'm in a cloud. 3,000 feet QNH 1014, so the altitude always goes with an altimeter pressure setting, because otherwise you don't know what that's 3,000 feet above. Is it 3,000 feet above the ground? Is it 3,000 feet above sea level? In this case, it's above sea level. And some timing information, estimating zone boundary 25, that means 25 minutes past the hour. And the next point, Omniglot 30, so 5 minutes later we'll get to the airport. And information Oscar says that we've received the ATIS from the previous slide and that they haven't updated the information since. So then we get a response from air traffic control, from the approach controller. Golf Oscar Tango, again the abbreviated call sign, cleared from the zone boundary to Omniglot, VFR, not above 2,500 feet, QNH 1014, Squawk 3513. Traffic is a westbound Cessna 172, last reported 3,000 feet, VFR, estimating zone boundary 27. So again, quite a lot of information, and at this point I've been scribbling this down on my paper pad while trying very hard not to miss anything. So cleared from zone boundary, that's given us permission to fly from the boundary where they control the airspace all the way to Omniglot. That's very nice of them, no complications there. But they've given us a restriction, not above 2,500 feet. That's probably because there's an aircraft flying the other way at 3,000 feet, right? So that means I have to descend before I get to the zone boundary. Squawk is an interesting word. It doesn't really mean go. It actually refers to the transponder, which is a piece of equipment that recognizes when you're being interrogated by a radar system and responds with a number. There is some specific phraseology around this, as one pilot found out when he was told incorrectly by air traffic control, squawk your altitude. Now, there is a correct thing that air traffic control could have said. They should have said squawk altitude, which means turn the dial to a position where it sends back extra information about your altitude. What actually happened was that this pilot was flying at 7,500 feet. Yeah, the people with pilot training in this room already know what's coming here. And so put 7500 into the transponder. He didn't think anything more of this until he arrived at his destination and was meted on the parking area by people with guns. The pilot should have known at this point that they're never going to be told to take their altitude and transfer it into the digits in the transponder. But this pilot did get confused and took it literally, forgot about the standard phraseology, and put in the international code for a hijacked aircraft. Hence the people with guns. So back to this. We then get a report of traffic westbound. So we're going eastbound. There's another aircraft going westbound. Last reported 3,000 feet, so that's where we were. Estimating zone boundary 27. So we kind of want to stay away from that. Let's start our descent now. And we have to read back. And the read back for a clearance has to be exact, word for word. And this is very important. If you don't do this right, air traffic control will insist that you keep doing it. Cleared from the zone boundary to Omniglot, VFR, not above 2,500 feet, QNH 1014, squawk tree 51 tree, copy traffic, Golf Oscar Tango. You don't have to read back all the traffic, just acknowledge that we've seen that, but the clearance has to be exact. Then they tell us Golf Oscar Tango, report aerodrome in sight. Wilco, Golf Oscar Tango. What does Wilco mean? Yeah, there you go. Will comply. It's one of the standard words. It's a lot more than Roger. Roger means I've received the message. Wilco means I've received it, understood it, and I will comply. When we can see the airport, Golf Oscar Tango, aerodrome in sight. And they hand us off to the next controller. Golf Oscar Tango, contact tower 121.725. Tower 121.725, Golf Oscar Tango, we read back. Fiddle with the radio a bit and say hello to the next controller. So there's quite a lot going on here, right? And this is all happening in the space of maybe 5 or 10 minutes. And you've got about 100 other people transmitting on the frequency as well, which I'm omitting because otherwise we'll all go mad. Omniglot Tower, Golf Lima Oscar Tango. Say hello to them. They say Golf Oscar Tango, join overhead, runway 10, height 2,000 feet, QFE 1002, report overhead. And we read back, join overhead, runway 10, height 2,000 feet, QFE 1002, Wilco, Golf Oscar Tango. Join overhead is a specific procedure which relates to where we're going to fly around the airport. And QFE relates to the altimeter pressure setting that we need to use if we want the height above the airfield. So in this case, it's a bit different, 300 or 400 feet difference. So it's kind of important that we get the right one. At this point, we'd probably change the altimeter now. Here's some diagrams to help you out a bit, because we've got to the point where this overhead join gets a little bit complicated, and we're using words to represent positions. So when we're overhead the airport, which hopefully is fairly self-explanatory, literally does mean overhead, we say Golf Oscar Tango overhead, and they respond Golf Oscar Tango, report downwind. Wilco, Golf Oscar Tango. So that's a nice simple one. After the really complicated messages earlier, we now get a little bit more time to think about what's going on. And at this point, we start following these arrows round until we get to the top right corner, which is the downwind position. That's our next call, as they asked us. Golf Oscar Tango downwind. They replied, Golf Oscar Tango number 2, follow the grob on base, report final. So this is quite good news. Number 2 means we're second in the queue. There's a grob, which is an aircraft type, that we're going to see in front of us and to the left, that are going to be on this vertical line here. Fortunately, we can see it. Keep a good lookout. And so we respond, number 2, grob in sight, Wilco, Golf Oscar Tango. Now we can hurry up a bit. When we get to this place, hopefully the grob's already landed. Golf Oscar Tango final. We get the response, Golf Oscar Tango, runway 10, cleared to land, wind 1206. So this is our wind information. We really like that when we're about to land because it affects which way we turn things. Runway 10, cleared to land, Golf Oscar Tango. We don't have to read back the wind, just the clearance. At this point we land, and the tower calls us and says, Golf Oscar Tango, vacate left. Vacate left, Golf Oscar Tango. That means take the next exit to the left. Golf Oscar Tango, taxi to parking via taxiway Charlie and taxiway Alpha. We read that back, taxi to parking via taxiway Charlie and taxiway Alpha, Golf Oscar Tango. We taxi to the parking area, turn off the engine, we've arrived. Welcome to Omniglot City. So this has been just an example of how standard phraseology is used and the sort of thing you can expect from it. It's very formulaic. All of these things work because we know what to expect. Like, there's a lot of very technical information conveyed in these radio calls, and knowing what's coming in which order really helps to understand that when you're listening to it in a difficult environment. And this is how standard phraseology has kept this flight safe. We've all arrived at Omniglot City in one piece and kept confusion to a minimum in this very technical and very difficult environment. And the final point here is that pilots and the ground personnel, so that's everybody producing the briefings, everybody, aircraft maintenance, air traffic control, we're all a team. There's no such thing as an individual pilot on their own. We're always talking to somebody, we're always working as a team to get the flights to progress safely to reach the destination. So I've overrun slightly. We've probably got time for maybe one question.
Without reading, the most common question so far is, how was it decided what units to use in aviation? You used feet for altitude and kilometres and metres per distance. Is this the same all over the world?
Great question. It's not the same all over the world. There are some parts of the world that use meters for altitude and some parts of the world that use feet for altitude. I think everywhere we use kilometers for visibility and nautical miles for distance. I'm not sure whether we use nautical miles everywhere. Probably there might be kilometers somewhere, some parts of the world. How it was decided, it was probably tradition. I'm not sure. Great.
Thank you again very much for your time.
Thank you very much.